Okay, 1.6. Continue. We need to, today we're going to look at when you have an inequality statement and you need to solve for x. Yesterday you already knew what x was and you just needed to graph it. So you have something that looks like this. X minus 7 is greater than, or less than 4. What do I need to do to solve for x? Add 7, just like in an equation. So I get x is less than 11. Now, I'm not going to make you take 11 tick marks, but I do want you to have 0 in the picture. So I'll let you count by, you can choose an appropriate scale. I'm going to count by 5s. So that, but then you do have to mark where the 11 is. Open circle at 11. And we graph to the left. Okay? So how about the next one? X plus 3 is greater than or equal to negative 1. What do I need to do? Minus 3. So I get x is greater than or equal to minus 4. And I go to the right on this one. Solid dot for the equal sign, open dot for no equal sign. Okay, any questions about that one? Okay? Now I'm going to kind of whip through these. If I'm too fast, let me know and I can go back or wait a minute if you need me to. Okay, negative x is less than 18, or negative 2x is less than 18. How do I need to solve this one? Okay, you're going to divide by negative 2. Now here comes the spot where it's different than an equation. You have to flip the direction of your less than greater than sign. So it's now x is greater than negative 9. When you divide by a negative number, change the direction of your less than greater than sign. So let's 0. Open circle. And we're going this direction. Okay, same thing is true for multiplying. So this time I have x over negative 9 is greater than or equal to negative 2, so I have to multiply times negative 9 on both sides. When that happens, I need to change the direction of my greater than sign. So I've got x is less than or equal to a positive 18. Okay, we're going to count by 5s again. 5, 10, 15, 20. Yep. 18's right there, and I am less than. So solid circle because it's an equal sign. And then I go that direction. Okay, questions on those? So if you add or subtract, it doesn't affect that symbol. When you divide or multiply, then it's only by a negative number. You'll notice I put over here on the board a couple of examples. If I divide by a positive number, the symbol stays the same. If I divide by a negative number, the symbol has to switch.
Wait, why does it have to switch or what?
Just when it's negative?
Just when it's negative.
That's multiplying and dividing?
Multiplying and dividing. Yes.
Why?
Because you're changing the signs, and if I make this statement, I'll just put it up here. I say x is greater than 9. Oh, we'll stick with negative 9. So same one I got here. Okay, now I'm going to multiply both the top and the bottom, or both sides, by negative 1. It says negative x is, now if I leave it like this, if negative x is greater than 9, is that still a true statement?
Yes.
No.
No.
If I switch it this way, then it is a true statement. Okay, so it's because of the sign issues and what that does to less than and greater than. And a lot of it comes from the way we use our numbers. When we're going positive, these should be negative, by the way. When we're going positive, the numbers go from left to right, and they get bigger and bigger and bigger. Well, when we go negative, we start with the little negative numbers and go towards the big ones. And when we look at greater than and less than, it behaves differently. Okay. Okay. So now, what does it look like? We have expressions on both sides, same kind of deal. What do I need to do here? Okay, we can do minus 5x from both sides, and I get 2 is greater than 2x minus 4. Add 2, and I get 4 is greater than 2x. Now I'm going to divide by a positive 2, so I don't have to change anything. I get 2 is greater than x. Now, for a final answer on these, if you do it this way, yep.
You move the 2 to that side.
Oh. That's...
Oh.
So we probably want to add 4, huh? So that makes it 6. Over 2. Is my arithmetic okay now?
Yeah.
Okay. So I have 3 is greater than x. Then, when you write your final answer, I want you to put x on the left, though. I want you to write it as x is less than 3 for your final answer. Certainly okay to do that. You don't have to deal with the negatives. But for final answer, still move your x over. Okay, then we'll graph it. Circle. Okay, this one, how should I do this one?
Plus x.
Plus x, okay. So I get 3 is greater than 2x minus 9. Then what? Plus 9. 12 is greater than 2x. Greater than.
What's the last example?
Nope. I'm going to divide by 2. And I get 6 greater than x, or the final answer, x is less than 6. Open circle, and I go okay, a couple more here. Now, remember our special cases with the ands and the ors. We're going to look at how we solve when we have ands and ors. The first one is an and problem. If you have an and problem to solve, you're going to want to probably put it in this form if it's not that way already. Okay? When you solve one of these, sorry, what you do is you look at the middle part, and I want to get x by itself in the middle. So I'm going to say plus 10, but when I do that, don't have to just do it over here. I also have to do it over here. So when you have one of these, there's going to be 3 of whatever it is you do. So negative 4 plus 10 is 6. 6x, those go to 0. 14 plus 10 is 24. Okay, does everybody see how that works? And then when you divide by 6, you have to do it in 3 different places. So I have 1 is less than x, which is less than or equal to 4, and then you know how to graph those. Open circle at 1, closed circle at 4, and you shade between the 2. Okay? Then when you have an OR problem, essentially you just have 2 problems to solve. So you just solve them separately. So the first one, I have 3x plus 5 less than or equal to 11, so I subtract 5 from both sides. I get 3x less than or equal to 6. Divide by 3. X less than or equal to 2. Solve the second one. Add 7. I get 5x greater than or equal to 30.
Do you want some dessert? Because my grandma brought me 4 pans of pretzel dessert. She brought me mud cake and cupcakes.
I appreciate it, but no thank you.
Because you don't need sugar.
Okay, then we're going to divide by 5. And I get x is greater than or equal to 6. Now, when you have an OR problem, just like when we did it before, it's this or that, so you're just going to graph each one of them. Now, x less than or equal to 2, I go this way. X greater than or equal to 6, I go this way. Okay, so the OR problems, you just solve 2 of them. Now, there's a couple of special cases I want to look at, so I have one more slide to show you. It'll be a quick one. What happens when I have x greater than 4 or x less than 8? Let's see, we got 0. 1, 2, 3, 4, 5, 6, 7, 8. Should have started over a little farther. Okay, I have an open circle at 4. And I'm going to go right. I have an open circle at 8. And I'm going to go left.
Doesn't work.
Well, it does work. It's or one or the other has to be true. How much of the number line have we got covered? All of it. So the way to graph this is going to be the whole thing. The answer will be all real numbers. Okay?
Holy crap.
Now, another special case. When I've got 8 or x greater than 8. So here's my 8 out here. I'm not going to do the whole thing for this one. I just want to do it quick. X less than or equal to 0 goes this way. Now, for and to work, both things have to be true. Is there any place where both of those are true?
Never.
Never. So the answer is the empty set.
Wait, why
Okay.
is that never true? Because meant to be equal to 0?
No, because they don't ever overlap. If it's and,
Oh.
it's where they both are true.
Oh, it's and. I thought it was or.
Okay, yeah. If it was or, you just leave it, you'd be done. If it's and, they both have to. Okay, any questions?
Anybody get one? I got that.